Good morning, all. How are you doing? I hope you are doing great. Today, we are going to do chapter number 2, which will talk about database environment. Okay, so let's go through the chapter learning objectives. We are going to discuss a few things about the database environments in this chapter slide, which includes the 3-level database architecture. Okay, we know that the database includes a data structure called schema. All right, so what is the meaning of a schema and why we need to have 3 levels instead of schema or sub-schema? All right, so we will discuss the purpose of having 3-level database architecture. We are going to discuss the 3 levels, which are external level, conceptual level, and internal level. All right, so these are the 3-level or the database 3-level architecture: external, conceptual, and internal. Then we will discuss the external and conceptual level purpose. This is one, external conceptual, because there are mappings between these 3 levels. So the first mapping will be external conceptual mapping, and then there is conceptual internal level mapping. So you're going to talk about them. Then we will focus on the definition of logical and physical database independence. Okay. We will differentiate between DDL and DML also. We will talk in more details about DDL and DML. We mentioned that in chapter number 1, in the previous chapter, but we are going to give more information about DDL and DML and what is the relationship between DDL, DML, and DDL plus DML with the relationship with external or the 3-level architecture. Then we will go through the data models. We will start talking about data models and why we need to have data models. Okay, because as a start, okay, we will talk in the first part of this chapter, we will talk about 3-level. It's kind of representation of the database, how it's being represented. All right, and externally, conceptually, and internally. And then how we can represent it in a way that it will be more understandable by end users, or for example, the designer of the database system. Okay, so in the second part of the chapter slide, we are going to talk about the data model. All right, and what is the importance of the conceptual modeling? All right, and what are the main functions of the database management systems? Functions of the database management system. And what is meant by system catalog? We have mentioned all these terms, right? But in this chapter slide, we are going to give more information about them. What are the main components or software components of the database management system? And then we will discuss the architecture of client server. And also this was discussed before, client architecture and what are the advantages and its advantages. Then we will talk about transaction processing monitors. All right, so in the first part, we will focus on the representation of the database in 3 levels or 3-level architecture. external, conceptual, and internal. Then we will talk about the data models and other functionality of the database management system. Actually, I'm working on chapter number 1 summary, or let's say activity. So once it's ready, I will share the link. All right. Because that way you will be able to get the information understood, okay, in a better way. All right. Okay, let's go through the 3-level architecture. As a start, okay, we need to know that the terminology or the architecture, the first architecture was produced in 1971 of the database, and it was including only 2 levels, all right, or 2-level approach. So in 1971, the database systems includes only 2-level approach or 2-level architecture, and the system view was including or consisting of the schema. This is level 1, all right. Sorry, this is okay. Let me just make it zoom in. So the schema, and this is level 1, and subschemas level 2. All right. So schema, we learned about the schema. We said it's the data structure, right? Or database structure is known as schema. All right. But later on, there was the American National Standard Institute, or by short we can call it ANSI, okay? American National Standard Institute, with the Standards Planning and Requirements Committee. So these two institute and committee. So ANSI-SPARC. So we can call it ANSI-SPARC. They produce similar architecture, but including 3 levels. All right, 3 levels considering the system catalog or description about the data. Because schema and subschema was very simple and representing the database, excluding any description about the data, all right, or how it's being stored in the system. So after 1971, we know that, or in 1971, what is produced? Which architecture? The 2-level approach, including schema and subschemas. But later on, the ANSI-SPARC produced the 3-level, including the system catalog. What are the 3 levels and how it's being represented in the database system? Let's see how we can represent these 3 levels in the database system. So 3 levels can be described as external level. This is number 1, which is the user view level. All right, this is the external level. If you can see this this figure, it illustrates how the levels are being represented in the database system. So anything about the user in the real world, representing data about user or require the interface of, or views, let's say views of every user, will be represented in the real world, will be called external level. All right, so it's describing the way the users perceive the data. All right, based on each user requirements, there will be a specific view or the way that will be matching with the user requirement. For example, user number 1 will gonna have view number 1. User number 2, we're gonna have view number 2, and so on. All right. User N, we're gonna have view N. For example, in the University of Bahrain system, I am user number 1, or faculty members are user number 1, for example, and we will have view number 1, which is not shared with user number 2. For example, let's assume that students are user number 2. Okay, So this is that the data will be represented to users in views. In which level? External level. Yes, ID is just a characteristic of what the user requirement, something to describe some information about the user. Yes, like user ID. I'm gonna have user ID as well, but it will be different. My ID will be my CPR, okay, as a faculty member, but your ID will be different, okay. So the view will include not only the ID, will include the name, will include more links. For example, if we are talking about SIS, the user view of students will be student timetable, student schedule, for example, adding or dropping courses, which will be hidden from my view, right? It will not be shared with me. This information will be hidden from the faculty members. While at the same time, my view as a faculty member will include my ID number, my name, my, for example, let's say e-services, okay, including advising list, for example, okay, my timetable. So advising list, for example, it's not shown or displayed to the other views, right? It will be hidden. So that's the point of having views. And all these will be included within the external level of the database. The way the data is represented in the real world, depending on each user requirement. Okay, so this is the external level, or how the data will be represented to users, or we can call it user schemas. Okay, what we can say here, how many schemas we have here in this example, in this figure. User 1, user 2, user n. So how many schemas here? User schemas. Yeah, exactly. So three schemas we can see in the external level on the top, which comes on the top. See, I will zoom it in more. Okay, what comes next? The conceptual level. I'm just giving you some simple information about them. Then we are going to discuss them and go through or go deeply into their definitions, okay? The conceptual level, which is number 2, so this is number 1. The conceptual level, it's the community level, or we can say it's the data is stored logically. All right, so the data is stored logically in the conceptual level, and it will provide mapping between two levels, between external and internal. All right, there will be both mapping and the desired independence. So there will be mapping and independence between external and internal levels. It comes in between, right? This comes in between the external and internal. So in the user schemas, or external level, we can call it, it will provide data about the real world. There might be entities like what you have mentioned, Qasim. You have mentioned ID number, for example. It might include some entities, relationships between entities, attributes, but in the real world. All right, it can be represented in the real world, and it is not mentioning anything about how this data is being stored in the database. So it's independent from the physical representation. Okay, let's talk about conceptual schema, which comes in between. This, the community schema, we can call it, it is representing data logically in the database and provides mapping between the external and internal level. Like, for example, the entities, relationships, and attributes and other constraints will be represented logically not in the real world, logically. For example, like we have mentioned before, student can be like represented like this, or for example, there are relationships between. This is just an ER diagram, so we can say this is an entity, this is another entity. There are a number of attributes inside. So this is logical representation of the data, which is called conceptual schema. Okay, conceptual schema. So it's like it has only one schema for the conceptual level, and it represents the data logically, like representing entities, relationships, and other attributes. Okay, talking about the third level or internal level, it's the way that the database management system and operating system perceive the data. Okay, see the difference? So here we are talking about physical schema, and the internal level, it's like the way that the operating system or the database will be perceiving the data. So internal schema, there will be under the internal schema, there will be a physical representation of the data in the database system. Okay, so this is how we can describe the three-level architecture. So got the point? Now, as a whole picture of how we are representing the data and the database system as a three-level NC Spark architecture, we know that there are three levels, right? Okay, simple. The external level related to users or user schemas, how each student, how each users can perceive the data depending on each user requirements. Then number two, conceptual level, which provides the mapping between the external and internal level. Then comes the internal level, which is focusing on how the data is being stored in the database, or how the data will be represented, considering the physical representation. And the data will be stored here with all physical data along with the system catalog. So this is the ANSI Spark three-level architecture. Got the point? Do you have any questions so far about this before we go through more discussions or more details? The second level is the conceptual level. This is where we can represent the data, like, for example, if we have, for example, let's talk about this SIS, okay? How we can represent the data logically. We can have student, and student will include ID, name, will include everything will be represented logically. All right, we will talk about it, Qasim, don't worry. Now you will have a better understanding when we are describing or when we are defining each level in more details. Okay, so don't worry about it. We will talk about them now. Now, why we have to use the three-level architecture? What's the reason? Now, we know that the main aim or the main objective that we have, we need to get three-level architecture, is to separate each user view of the database from what? From the physical representation of the database. So this is the main point of having three levels. All right, we need to see here why we need to have three separates, for example, or more than one separate user view from the physical representation of the database. Why? For what reason? Because there are so many reasons. Okay, this is the main point of having these three levels. Why? Because every user needs a customized view based on the user requirements, right? Me as a faculty member needs to have my customized view, and you as students need to have what? Customized view. It depends on our requirements, right? Because my requirements from the system differs from your requirements. You need, for example, to add and drop courses, but I don't need that. So there must be a mechanism that have or separates my view from your view, right? So this is the point. I'm separating, okay, each user's view of the physical representation of the database, because every user every user or each user should have his own customized view, another way to access same data. Okay, another interface, in other words, another interface. And you must be able to change the way you view the data without affecting other users. Okay, so this is another reason. So reason number one, each user need to have his customized view. Reason number two, why we need to separate it from the physical representation, because we need to have this ability to change the view, my view. I have the ability to change it without affecting your view, for example. Okay, what is the reason? What is the third reason? Sorry, we need to deal, you don't have to deal with directly with the to deal with the physical database storage details. Okay, that's how we can understand it, because if you deal directly with the physical representation, okay, that this will affect my view as well. So there must be no direct connecting between the user and the physical representation of, or connection, sorry, connection between you as a user with the database, directly with the database. For example, how it's indexed, the data is indexed. You are not aware of how the data will be, or what is the indexing used within the data, what are the file formats, what is the file structure, okay? How many users are being used or are using this database or this, for example, user view. So you are not aware of all these details. You should not have any direct connection between you, your user view, and the database itself. Database administrator, so reason number four, database administrator must be able to change the storage structure without affecting your view or user view. Okay, so any change, any modification by the database administrator will not affect any of the user views. This is another important reason. Number five, the database administrator also should be able to change the conceptual structure without affecting all users. Okay, we will talk about this conceptual structure. Storage structure means we are talking about physical representation. Okay, something about related to physical representation, where the data is being stored, which file format, which location. You know that, right? So the storage structure means the location, the file path, where it is located, all right, and what is the file format, everything about the storage. This is done by the database administrator. So when or whenever the database administrator is changing the physical structure, the storage structure, for example, or the conceptual structure, this must not affect any of the user views. So these are five main reasons, okay, that tell why we need to separate the user view from the physical representation of the database. Yes, exactly. It will be the same without any change. Anything changed or modified internally will not be seen or displayed. You will not be aware of any modification internally, any internal modification. All right. But in one case only, if they change, for example, the way that the data will be represented in each user view, for example, a new record will be added to student view. Okay, this will be reflected, of course. Any update, adding a new field or adding a new attribute. For example, address is added, address field for student address, for example, is added. This will be reflected, or this will be shown or displayed in your user view, of course. Okay, only in that case, if it is linked to the user requirement. All right. Now let's talk about the external level. What does it mean? How we can define the external level? So this is level number one. Number one, external level. As we said, this is the user's view. Okay? External level means what? User's view. Users views can be and more than one view, more than one schema. All right? So we can describe a part that the user will perceive the data. How the user will perceive the data, this can be described in the external level. It contains a number of different external views or schemas, and it's as I mentioned, these views are in the real world. It can include some entities, attributes, relationships. يعني, for example, I'm saying the student has an ID, student has a name, there is an email, right? There is all these things will be described in the real world. How we can perceive it in the real world, not internally, not conceptually, but externally, something related to you, how you can understand the data in the real world. Okay, and you are interested in, for example, other things like how the student will be adding a course, okay, and what is the relationship between the courses and the faculty member. Okay, this part of a database, it will be hidden from you. You will be not aware, okay, of that. So only something you are aware of. Your name, your ID, your personal information, your timetable, okay, your or any recommended courses to be registered by the students, something related to your plan, to your program plan. But for example, are you aware of the courses offered by the business college to students from, for example, 2018? No, you are not aware. Why? Because it's not linked to your real world or something you are interested in. Okay, so this is the meaning of external or external level view or user's view. Now, different users may have different views of the same data, which means, for example, some users' view might include day, month, year for the date format, and others it's the same data. Okay, others can be in this format: year, month, day. So it can happen sometimes. These information can be in different formats, but the same data, but it will be represented in different formats, like the date, like this example. Some, yes, exactly. This is also a customizable way. You can have sort, or you can sort things, or you can decide which format you are going to have, or you can decide which, for example, field to be listed first, okay, or sorting. Now, some other views, we can call it derived views. Derived means it's based on other data, or it will be calculated based upon another data, okay, or other data. So it will be stored and created when needed, only when needed. For example, if you have the date of birth, you can calculate what? You can calculate the age. Is this age, is it existed? It's not existed. It's derived. We can call it derived, okay? So this is an example. Or you can have two or more entities combined together. Okay, like for example your timetable, it's combining the course, okay, and the section, for example course and section, and the faculty member. This is just an example. So some views of or of any user, it depends on the requirements. Yes, exactly. No, it's created or generated upon request. Okay. For example, I can send a query to the system that I can create a query that calculates the total of, let's say, for example, me as an instructor, the total of quizzes, total of quizzes. For example, we have quiz number 1, quiz number 2. The total is not existed. The total field is not existed, but it will be created based upon quiz number 2 and quiz number 3. Based on quiz number 2 and quiz number 3. So it will be calculated. This is the meaning of derived views. It's calculated based on other records or other data. Got the point? Some other views are combined from different entities. For example, I combined, let's talk about if we have first name, second name, last name, or family name. These are separated in different entities, okay? Or sorry, different fields, right? So first name is in one field, second name in another field. If we combine them together, full name, we will have full name. Full name is not existed, but it's combining other existed fields. Got the point? So some of these views might be, and some user views, so different views like having the same data but in different format, or derived views. Okay, now let's talk about conceptual level. Number 2, conceptual level. As I said, it's a community view. We call it community view. It describes what data to be represented. So we are talking about here, we are talking about what. Okay, what data to be stored in the database, and what are the relationships among the data. All right, so what data means what? Means representing entities, relationships, attributes, and constraints, but in logical way. So it contains the logical structure of the entire database, as seen by the database administrator, not seen by the user, not interested by the user. Okay, so as seen by the database administrator. So it will consider the data requirements of the organization, but it's independent of any storage consideration. It's not including any physical details or any physical data about the database. So it's not representing the data in physical as a physical schema. Okay, it's logical, not physical. Now, what is it's represented in the conceptual level? Here, focus Qasim. Here, it represents all entities, the attributes and relationship, any constraints on the data. All right. Some semantic information about the data also can be represented, in addition to security and integrity information. Some security, like security mechanism, integrity mechanism, how the data will be consistent, some information about how the data will be accurate in the database, it will be also represented in the conceptual level. All right, and this puts this in your mind that this representation will support the external view. Okay, it will support it and it will be available whenever the user will derive some information or data from the conceptual level. I will discuss this now, how this will be represented. See, this is don't worry about it. It's just an ER diagram, entity relationship diagram. It's just an example for you, showing you how the data is represented. This is actually a data model. This is a data model. And how the data is represented in the database it's not coming like this, okay? This is just a model that is drawn by some kind of specialist. They are responsible of creating or having a data model to represent the database in a conceptual or logical way. Sorry, just a minute. Okay, you will be able to understand this more in the next chapter slide, the next chapter. So don't worry now. It's just an example. Like, let me just give you an example here, a very simple example. When the client, here we have an enterprise, okay, including different entities. Entities can be represented with this rectangle shape, okay? I drew this before, right? I've mentioned this before. I show you how this to be represented logically. So if the client, including the client number as an attribute. So this is what I'm talking about. The client. This is the client entity. Okay, including what? Client number attribute. This is the main, or we call it primary key. When the client register, okay, registers in a branch, this is another entity, okay, and or registered by the client staff member. Okay, so this is kind of, and there is relationship. There are relationships among them. At the same time, the client will state preference. Okay, this is a relationship. And preference is another entity, which is called client preferences. Also, the client will hold a lease. This is another entity. Okay, and hold is a relationship. Got the point? Got it? How it's represented logically? Is this how any user view can perceive or not? Now get the point, Qasim? How the data is represented conceptually or logically? This is the way. You are describing everything. Client, what is the attribute? Client number, client states. So states is the relationship. State what? State another entity. Preference, okay? And what is the other relationship? It's more complicated, right? And you as a user will not be aware of all these things, right? Yeah, you are not able to get this. This is another structure. It's a community structure. Community about all data stored in the database. All right. Same with this picture, and you can see you, for example, as a house owner. Okay, you are not an engineer, right? You don't have to be aware of all these things. Only what you will be aware of how to use every part of your house. For example, how many, or the general structure, the user view of this house, how it looks like. It looks like I'm having one kitchen, one garage, right? And the whole area is like, for example, 100 by 200 meters, for example. This is just an example. And there are 2 floors, right? This is just general representation of how the house will look like to the user. Okay, so for example, let's assume that I'm looking for a house. I am planning to buy a house. The owner will provide this to me, or will just show me the house, how it looks like, the rooms, how many floors, the overall space. You get the point? This is the difference. This is the difference. So this map will be like a conceptual view, logical view of the house. Okay, just all right. So it must not, as we said, it must not contain any storage dependent details. This conceptual view, it must not include any storage dependent details. Like, for example, if I am storing data about entity, okay, and the entity will include only data type. What is the type of each attribute? For example, ID must be a number and must be, for example, 9 characters. Okay, but do I have to mention how many bytes it's occupied? No, it's not mentioned, right? So in the logical view or logical level or logical schema, only data about the description about the entities and attributes and constraints, and sometimes about security and integrity, will be represented. And it will be not including or mentioning the storage details or data, like how many the file size, or how many bytes for each attributes. Okay, so let's talk about the internal level. Internal level, we said it's the physical representation of the database on the computer. So here we will talk about the storage dependent data. Okay, so the storage dependent data will be represented within the internal level, the physical representation, because it describes how data to be stored. So here we are talking about how. Okay, how data to be represented or stored in the database system or in the database itself. All right, but in the conceptual, we are talking about what data, right? What data to be represented and stored. Exactly, Qasim. In the internal level, we are talking about the data type, sorry, the file structure, the file size, how many bytes for each attributes or for each entity, for example, to be occupied. So it covers all physical implementation and the performance of the database, the storage space, utilization, everything that will be represented here. And the data structure and the file organization. So the data structure, so everything mentioned here will be represented or considered at the internal level. So file organization used to store on storage devices. Even the storage devices will be considered here. So everything about storing the data. What are the, for example, the methods? There are methods, some methods for storing and retrieving the data. To do what? To place it in the storage devices, okay, to be stored in the storage devices, to build the indexes, to retrieve the data. So it works with operating system access methods. Okay. So it interfaces with what? It works with operating system access methods in order to place the data in the storage devices, in order to build indexes, in order to retrieve. And it concerns with storage space, as we said, allocation and data indexes, record descriptions with, as you said, sizes, file sizes, record placements, data compression. If there is any encryption technique, it will be considered here. All right. So this is for, sorry, for the physical representation of the data. Now, after this, you can see that the internal schema The database itself will have the physical level. Okay, the physical level, it will be managed by the operating system and under the direction of the database management system. So it will work together, but this may vary from system to system because it depends on the operating system. For example, some database management system use the operating system access methods, okay? But others will use only basic ones, or it's specific access method, not for the operating system. It's not using all the operating system access methods to create or to store the files of organizations. Okay, so this is the physical level. It will consider the physical representation. It's the database itself. Same as this is what we can see in the internal level. Some operating systems are some operating systems have some access methods used by the database management system. Some others are not using any of these access methods, but it has its own access methods to create its own files. It consists of items only operating system knows. So users or the conceptual level will not be aware, or the database administrator. So only the computer or the operating system or the technician will be able to understand these items. For example, how the sequencing is implemented, how it's implemented, whether it's of internal records, it's stored as continuous bytes on the disks. So it's all considering the physical representation on the storage space. Okay, all right. And inshallah, next time we are going to discuss the schemas and how we can map between these levels. You will have a better understanding about these levels. As we said, just before we go through this next time, external level will have its external schema or sub-schemas. Conceptual level will have a conceptual schema. It's the same. It works in parallel. So conceptual level means there is a conceptual schema. And internal level will have an internal schema, and how we can map between these schemas. Okay, so we stopped in this slide. So that was all for today. Thank you for attending. Do you have any question? Is there any question? Guys, everything is clear? All right. I have a summary for this chapter slide, by the way. There is, I have summarized some of the information. I will share it with you. Inshallah, it will be useful. All right. Thank you so much. يعطيكم العافية. Inshallah, see you next time. Bye-bye.